had any good cases in a while.
I know. It's the night shift.
It's the worst. Rapunzel's missing. Rapunzel's our favorite cop dog. We have to find her.
I know, but how?
Well, she was taken by this shadow stranger. We'd have to go through volcanoes and snake pits and quicksand to find her.
I know how we can find her.
How?
Sine and cosine graphs.
Oh, what a great idea! But I don't really know how to do them since I'm new and all. Could you teach me?
Of course.
Ready to go?
Okay, Special Agent Davidson, since I'm a newbie, do you think you can explain our strategy to me? We need to find Rapunzel!
So you're saying if we graph sine and cosine graphs, we could potentially find the two pathways in order to get to the shadow stranger and save Rapunzel?
Yeah. Let's begin with the cosine function. So, with this cosine function, or y equals 3 cos x plus pi minus 3, we have to rely on our general formula for cosine, or y equals a cos b x minus c plus d. But I bet you're wondering, what do all of these variables mean? Well, essentially, we have 4 different possible variables in this equation. However, in every equation, you're not necessarily going to use all 4 variables a, b, c, and d. In this case, we have the variable d, or our vertical shift, which, like I said before, won't be used in every problem. But since we do have one in this problem, and it happens to be -3, if there wasn't a vertical shift, we would start at the regular amplitude of 3. But since there is, we move down 3 spaces, giving us a negative vertical shift of 3, which aligns with the problem. So actually, we start here at the origin in this case. Okay, let me just think. This thinking part is going to have to be edited out. Okay, so the next thing that I need to explain is what? However, we don't actually start at the origin because we also have another variable, c, or our horizontal shift. Now, whenever you're dealing with the variable c, or the horizontal shift of pi in this case, you have to take whatever the sign is in front of your variable c and move it in the opposite direction. Let's talk about the period. So when graphing sine and cosine graphs, you have to understand that the regular period is 2 pi. However, there is a variable b, which is 1 in this case, since there is no number attached to or outside of the x, that influences the period. So in order to determine the period, you have to follow this formula and divide 2 pi over b. So 2 pi divided by 1 in this case still gives us 2 pi, meaning we have a normal period or length along this x-axis of 2 pi.
So once you find the period, which in this case is 2 pi, you want to label the period according to your graph. So in order to do that, you need to split your graph up into 4 equal parts. You start over here on the end by putting the whole period, which is 2 pi. You'd split that period, the whole period, in half when you get pi. And then you divide the half by 2, where you get the fourth, which is pi over 2. In order to get the 3/4 mark, you add the fourth and the half together. You add pi over 2 and pi to get 3 pi over 2. And then once it's written all on the positive side, you just rewrite it on the negative side.
So now that we've explained the period and how to label the period according to the graph, we need to go back to our variable c, or in this case, our horizontal shift. Now, since our variable c in this case is pi, what you have to remember for all sine, cosine, tangent functions, doesn't matter, it applies to all of them, you're going to move the horizontal shift in the opposite direction of whatever sign is in front of your variable c. So, looking at this right now, you would assume that your horizontal shift would be pi in this direction, the positive direction to the right. However, always know that you have to change the sign and move the opposite direction. And that is where your graph really begins. So remember, we've shifted down 3 from our amplitude for a -3 vertical shift downward. And we've also shifted in the negative direction, remember changing that sign, -pi. So actually our graph of 3 cos x plus pi minus 3 will begin here. So again, Detective Sanchez, since we've already moved our vertical shift downward 3, relying on variable d, and our horizontal shift over here to -pi, this is going to represent the top of our cosine graph. So from here, we're going to rely on our amplitude, which is going to show us how far down or how far up we're going to move along the y-axis. Since this represents the top of our graph for cosine, we're going to move down 3 spaces and over to make a mark at our next length along the period, which would be -pi/2. And again, we're going to rely on our amplitude again and move down 3 to our next length along the period, down here at -6, and make a mark. And so we're going to move up 3 in this case, since we've moved down 2 to our next length along the period, pi/2, up 3 over one more length along our period to pi. This represents the top of our graph again, so we're not going to go any higher than this, and we've already moved up positive direction twice. So we're going to move now again in the negative direction by 3 to -3, make a mark here at 3pi/2. Same thing, move down again, down 3 over one more length along the period to positive 2pi and -6. And so as you can see, again, and the graph, obviously what you have to keep in mind is it can continue for, exactly. But we're only showing here the length of 2 full periods, 2pi to -2pi. And so, again, that would continue. But you can see the whole up, up, down, down pattern.
Dust yourself off and try again. You can dust it off and try again, try again.
Okay, so I think I get it now. So to find the period, knowing that it's usually 2pi, looking at x, there's no coefficient in front of it, so we're assuming that b equals to 1. So if we do that 2pi/b to find the period, 2pi would be over 1, and that would give us a period of 2pi.
Exactly.
Okay, so we're going to label the period, and we start with the whole period as positive 2pi over here, and then we split it in half, where we get pi, and then we break this half in half, and we get pi/2. And then in order to find the 3/4 of it, we do pi/2 plus pi to get 3pi/2. And then we repeat the same thing on the negative side?
Yes.
Okay.
Great work, Special Agent Sanchez. Okay, so now that Special Agent Sanchez has already explained how we obtain the period based on our graph of sine x minus pi/4, the next thing that it's important to understand is the difference between sine and cosine graphs, and that sine graphs always start at the origin, whereas cosine graphs, on the other hand, are going to start at whatever the amplitude is, which is 1 in this case, since there is no coefficient representing the variable a in front of our sine. So, unless there is a vertical shift, which in this case there is none, since we have nothing outside of these parentheses or no variable d. So we're just going to start at the origin. However, as you can see, we do have a variable for c, x minus pi/4, so we are going to have a horizontal shift, although we're not going to have a vertical shift, which, like I said before, all variables aren't necessarily going to be used in every equation. So, since we have a vertical shift, no, okay, just cut out that part.
Okay.
Okay, so since we have a horizontal shift, of pi over 4. Wait, is it pi? I want to say the wrong. Okay.
Yeah, it's pi over 4.
Okay, wait. Okay, so since we have a horizontal shift here, remember we're going to have to take the opposite sign of whatever is in front of our pi over 4, which is a negative, and move in the opposite direction. However, when we look at what we do have marked, what we know is that pi over 4 is 1/2 of something that we do have marked, pi over 2. So essentially, we're just going to have to go along and make marks halfway in between the ones that we already have. And we're actually going to be moving between these red marks from point to point rather than these black marks like we were before. Okay, and remembering that for our horizontal shift, we have to take the opposite sign. So positive, we have to move in the positive direction, pi over 4 along the x-axis, which is marked by one of our new red marks right here. So actually, we are still, technically would have started at the origin, but since we have a horizontal shift, we're starting along the x-axis at pi over 4. Okay, so as you can see with our horizontal shift, pi over 4, we're now going to move up 1, following our amplitude coefficient of 1 in front of the sign, or variable a, and then we're going to move back down 1 to our x-axis at our next red mark, down 1 again, and then we're just going to repeat the exact same thing on the opposite side. So, as we can see, we're just going to repeat the exact same thing on the negative side. So, as we have marked, we move down 1 to -1, negative pi over 4. We move back up 1 again at our next red mark, up 1, down 1 again, and again the same thing is going to continue infinitely on both sides, but again we're only showing here 2 full periods from -2 pi to 2 pi.
Oh, wow, so it makes a wave.
You got it, Special Agent Sanchez! Okay,
Alright, so Special Agent Davidson, it looks like the sine graph right here that would only has 2 obstacles we go around, the wild jungle and the volcano, it doesn't get straight to Rapunzel. But if we take the cosine graph, even though we have to go around the bat cave and the snake pit and the quicksand, we go straight to her.
exactly! Let's go save Rapunzel!
Woo!
Oh, Rapunzel, they'll never find us. We're gonna have such an evil, wonderful life together. They'll never be able to catch us. The Shadow Stranger. Put your hands up, Shadow Stranger. We'll take that dog back. Rapunzel! She's coming with us! You're under arrest! You have the right to remain silent. Anything you say can be used against you in a court of law. You have the right to an attorney! Rapunzel! So with that, Rapunzel, thanks to our sine and cosine graphs, we hope you guys understood everything.
So until next time, this is Special Agent Davidson
And Special Agent Sanchez
signing out.
Say what?